All right, welcome back everyone to another video. Where am I? Okay, so we're gonna start with a joke, a great one. Okay, why did the frog take the bus to work? Because his tar, oh, stuffed that one up, didn't I? Because his car got towed away. Toad, frog, toad, ribbit, frog. Okay. I hope you guys love these jokes. They're gonna be consistently great. Okay, now what we're looking at today is we're looking at areas of compound regions, very, very similar to the video before. Check out my playlist. So this time what we're doing is we're not just working with one curve, we're working with multiple curves, okay? And so it's very, very similar to the process that we did for finding an area under a curve. The only difference here is now, because there's two, we're gonna have to do a little bit more calculation. So in general, when we're solving any one of these questions, and I'll model it for you, I'll need you to sketch all the curves. So that means you'll need to know how to sketch functions and all of that. Now, this is the important one that you didn't have to do before. You'll have to find the points of intersection because that's going to tell us exactly where we need to integrate in between. Okay, the points of intersection is normally what will bound a function or bound an area. Okay, and then 3 and 4 is very similar. At that point, you can determine the integrals to calculate. And then for part 4, you're going to calculate and answer your question in the correct units. Cool. So if we just move on, let's take a look at this one here. We want to find the area of the region bound by y equals x minus 2 squared and y equals x. So let's just use two different colors here so we can kind of differentiate which one's which. Okay. Now, it's not going to be a lesson on sketching. So if you need to go back and figure out why I did what I did, you're going to want to do that. But again, y equals x minus 2 squared, that is just going to be your parabola shifted over 2 units towards the right. All right, and then we've got this y equals x line, which is our nice straight line, kind of going straight through. And the area of the region that's bound by these is actually going to be this guy in here. Okay, that area right in there. Okay, now we've done that, we've sketched it. The next thing we need to know is we need to know what these points of intersection are, because that's going to tell us where we need to integrate. So how do I do that? So points of intersection, I'll write this down here. And let's use a different color. Okay, so points of intersection. How do I find a point of intersection? Well, correct, it's going to be by simultaneous. You could have said something completely different, but I wouldn't have known, whatever, but I'm assuming that in a point of intersection, simultaneous. So they're both equal to y, so I'm just going to let this equal x, take away 2 squared equals to x. Now, for me to solve this, I'm going to need to expand everything out. So it's going to be x squared minus 4x plus 4 because it's a perfect square equals to x. Now I'm dealing with a quadratic, so I'm going to move everything to one side. I've got x squared minus x, so that's going to be minus 5x plus 4 equals to 0. Now to factorize this, I'm going to get x minus 4, x minus 1 equals to 0. So from here, I can see that x would either equal to 4 or x would either equal to 1. Okay, so looking at that, I can see that my boundaries here, my x values, that's where I'm going to be integrating in between 1 and 4. Okay, now that we've got that, the hard part is basically over. All I have to do now is find the correct integration. Now, I want you to kind of see it as if this is how we're going to find the area. But if I integrate under that green line, to find just the shaded region, I'm going to have to minus one region from another. So the way I look at it is it's kind of going to look like this. The area that we want, bear with me here. The area is kind of like this. That area that we're looking for is going to equal to the area under the green, which in this case is actually going to be some sort of trapezium. There it is. And then what we're going to do is we're going to take away the area under this one. All right, we're going to take the area underneath that, and we can kind of see that the area that we're going to take away that's under this curve is kind of like this, right? And I'll kind of show that there. All right, so we're taking away the big area, take away the little area. So hopefully that's enough for you to be able to kind of see. I know it looks a little bit cluttered, but let me show you what that means. So the integration of this would be the integration of, now first, if I want to find the area under the straight line, because that's the one that's on top, I'm going to do the area, the integration between 1 and 4 of my x line. It's going to be x dx. Okay, that's going to give me my total area. Now what I'm going to do is I'm going to take away the area that's beneath that red parabola. All right, so I'm taking away what's underneath. So if I take away what's underneath, again, I'm integrating between 1 and 4 because those are my bounds. And this time I'm going to integrate the parabola. Okay, now that's what we get here. Now, if I really wanted to, I could kind of mush it into 1 because we're using the same bounds. So it's just going to be x, take away, whoops, I should have written a square there, my bad. So it's just going to be x, take away x minus 2 squared dx. And then at this point here, you'll expand it, collect like terms, and you can integrate. Now, because today's lesson isn't about necessarily doing the computation, I'm going to leave that for you to do. But just know that if you can get to this line here, at this point, it's just a straightforward integration, and you should be able to steal some marks before you even calculate the answer if you were to get it in an exam. Okay, now just in case you feel like you weren't really tracking along, or there's a different type of example, let's do one more example, okay? Find the area of the region bound by y equals x squared minus 4x plus 2 and y equals to x minus 2. Now, this one here is going to be a parabola that doesn't factorize nicely, so we're going to have to find out things about it in a different way, and we're going to get a different line here. So let's start with this one. If I can't factorize it, I'm going to find the axis of symmetry, which is, x equals to minus b on 2a. And in this case, minus b would be positive 4, 2a would be 2. So I get x equals 2, that's your axis of symmetry. Okay, now we've got the axis of symmetry. What we're going to do here is we're going to find the vertex. So by substituting that back in, we get 2 squared minus 4 times 2 plus 2. That's going to be 4 minus 8, that's negative 4 plus 2, that's negative 2. So I can see here that my vertex will be almost negative 2, 2. And I should probably try to make it somewhat likely. Okay, so that's 2, that's negative 2. That's my vertex, and I'm actually going to be somewhat of a positive parabola. And let's do that in red, right? It's going to be something like that. Okay, not perfect, but it gives me an idea. And then we've got y equals to x minus 2. That there is just going to be a straight line. It actually is going to go through the minus 2, and it's going to have a gradient of 1. And you can see here, if I just move that a little bit, we're dealing with some parts that are above the x-axis and some parts that are below the x-axis. I'm going to do the total area with this green thing here. Okay, now, what we can do is we can break it up into lots of different parts, but here's the beauty of finding area of a region. All I need to do is do the integration of the top and then minus the integration of, I guess, all the area that's kind of beneath it. Okay, so let me explain what that means. So first things first, before I even get there, let's find out what these intercepts are. Okay, so to solve it, I'd have to say, okay, intersection. So I've sketched it, that's my first step. Now I need to find my points of intersection. And let's let them equal each other. X squared minus 4x plus 2 equals 2x minus 2. Minus x from both sides gives me minus 5x, and then plus 4 equals to 0. And if you realize here, this is going to be the exact same as the previous question. Right? That's just by chance. It's not a thing. So we know that this length there is 4, or that x value there is 4. And this x value here is 1. Okay. Now that we've got that, we can see that our integration is going to be in between those 2 points. So I'm going to take a couple shortcuts here. I know that I'm integrating between 1 and 4. Okay, now what I'm looking at here is the function that's kind of on top that's going to give me the majority of the area is going to be that straight line, which we found out was x minus 2, right? That's what we sketched, x minus 2. Now what we're going to do is we're going to minus the integration between 1 and 4 of the integration beneath. Okay, so in that case, it's going to be the parabola, which is x squared minus 4x plus 2 dx. Okay, so that there becomes our integration. So hopefully you can see that from there. The great part about this is that we don't have to absolute value anything because of the nature of regions. It's kind of like they all cancel each other out and then it kind of pops out magically correct. Okay, so when you're finding area of a region, don't worry too much about like, oh, but it's under the x-axis. As long as you start with the function that's on top and then you minus the integration of the function beneath it, you're going to be fine. Okay. Now, I'm going to end the video there, kind of. So if you're done, that's it. Do the integration, do it yourself. But just in case you're a little bit stuck and you want some help with the integration, I'm going to do it for you. All right. Because, you know, I care about you guys out there. And I hope you have great lives. Okay, let's do this integration. Now I'm going to do a little bit of a trick here. Now, because these bounds are exactly the same, I'm just going to write it as if it was one integration. All right, so it's going to be between 1 and 4 x minus 2, and I'm just going to take away this whole second function, x squared minus 4x plus 2. All right, I lost that for a second, but I think all I need to do is well, I lost a little bit there. Let me pause. All right, sorry, we're back. iPad died, sad. Okay, so we're just continuing on. We put it into one integration, and then now I'm just going to clean that up a little bit. So I've got x, or I'm going to have negative x squared. That's fine. I'm going to have x take away negative 4. So it's actually going to be x plus 4x. That's going to be plus 5x. And then I'm going to have minus 2, so that's minus 4 dx. So I've just expanded the brackets and collected like terms there. And let's do this integration. Right, so negative x squared becomes negative x cubed on 3. 5x becomes 5x squared on 2. Sorry, that should be plus. And this becomes minus, man, making mistakes all over here, 4x. And it's going to be evaluated between 1 and 4. I thought I'd kind of go all the way through, but it looks like it's going to be messy and I'm going to need a calculator. So I'm going to stop there. Okay, now hopefully that helps. And I'll see you guys at a different time. Any questions, leave them below. See you later and bye-bye.